Picture yourself in a crowded coffee shop. You're sipping a latte and log into your bank account using the free public Wi-Fi. The moment you hit enter, your password becomes a signal floating through the air. Since it's a public network, that signal is out in the open, where a stranger with the right software could simply listen in and grab it. We rely on a field called cryptography to stop that from happening. Most of us imagine this as a single giant digital padlock standing between our data and the rest of the world. In practice, cryptography is a specialized toolbox. Inside, there are several different tools, and each one has a very specific job to do. Understanding how these tools work together is the reason we can shop, bank, and message each other safely every day, without the entire internet collapsing into a free-for-all. The first tool in the box is symmetric cryptography. Think of this as the lockbox of the internet. It uses one single key. You use that key to lock your data inside, and you use that exact same key to unlock it later. This method is incredibly fast, which makes it the best choice for protecting huge amounts of data, like everything stored on your computer's hard drive. But it has a major weakness, the problem of sharing the key. If you want to send this locked box to a friend, you have to find a way to get a copy of that key to them first. If you send that key over the internet, a hacker could intercept a copy in transit, making your expensive lockbox completely useless. To solve that sharing problem, we use the second tool, asymmetric cryptography. This works more like a street mailbox. This system uses two linked keys. First, a public key, like the open mailbox slot. Anyone can use it to drop messages inside. The second is your private key. This unique key opens the bottom door to retrieve them. You keep it secret. Because the locking slot is separate from the unlocking door, you can receive a secure message from a total stranger without ever having to meet them to swap keys beforehand. The third tool is hashing. While the other tools are for hiding data, this one is a digital blender used for verifying data. Hashing is a one-way street. Data goes in and blends into a unique digital fingerprint that can never be reversed. Change even one tiny comma in a document, and the blender produces a completely different fingerprint. This makes hashing the perfect tamper-proof seal. By comparing fingerprints, you can be certain that a file wasn't changed or corrupted while it was moving across the network. Now let's look at how these three tools work together the moment you log into your bank from that coffee shop. First, your computer uses the bank's public key, that mailbox slot, to safely deliver a temporary secret key. This solves the problem of sharing a key over an open room. Once that secret is safely shared, the computer and bank switch to symmetric encryption. Since they both have the key now, they can use the faster lockbox method to protect all the data you see on your screen. While that's happening, every piece of information moving through that tunnel is being run through the hashing blender. This creates a continuous seal that ensures no one is messing with your transaction as it happens. This three-step process happens in the blink of an eye, millions of times a day. It's the practical reason we can trust the internet with our most sensitive information. Cryptography is more than just complex math for experts. It is the practical system that keeps our bank accounts full and our private messages private. It provides the security that allows our modern world to work, helping us connect and share with each other across the globe. If this helped you understand how your data stays safe, please like the video and subscribe. And let us know in the comments, what other part of the digital world should we explore next?